Great. Thank you. All right. So today I want to introduce you guys to natural language processing, large language models, vibe coding, and context engineering. And of course, we have our YouTube channel on Tony Tech Insight. So if you haven't subscribed, please do also subscribe. Unfortunately, I didn't put the link to the YouTube page because I prepared this slide this morning. So forgive me for not putting the link. But do join because I put a lot of short videos over the week, which are quite interesting and also a way to guide you. I think the video I'm going to put after this class today will talk about all you need to know about AI. So such kind of video, I use visuals on such kind of things. So it should kind of keep it simple and help my audience to follow. So do well to subscribe so you can be able to watch some of this video. So the major learning objectives today, by the end of this class, I expect you to understand what natural language processing means, or NLP in short. What are some of the NLP techniques? Their evolutions into the current large language models we have today. Secondly, I expect you to be able to grasp how large language models works under the hood and their real-world applications. Again, don't be scared because I won't really go into the mathematics. It's just to pinpoint how these things work and you can be able to understand it so you don't think it's magic. So then thirdly, I'm going to teach you guys on what vibe coding means as a low code medium. And then I'm also going to show you about some of the methods on how you can experiment vibe coding using LLM. Although we are not really going into the hand-on sections because I want hand-on sections to be hand-on sections. So most of the time, I will just show you snapshots. So during the hand-on sections, which will be starting soon, it will be more about practicing these things together. So that will be much more better. Then I also want to show you guys about how you could master context engineering, which gives you better outputs, than prompt engineering. But don't be scared when you hear vibe coding and all that. These are examples of prompt engineering. But again, the engineering is not to scare you, it's to tell you about the structure. Because when you talk about engineering, it's when something is structurally organized in such a way that it could be able to execute routine tasks. Okay? All right. So what is natural language processing? You must have heard people talk about natural language processing. If you are in the field of computer science, if you're a statistician, you must have heard this, and even if you are not, you must have heard people mention it. So natural language processing is a subfield of AI that enables the computer to understand, interpret, and generate human language. So think of it as when we are trying to teach the robot how to read between the lines, emails, tweets, or novels. So the reason is because communication is the language that humans express their emotions, they express their thoughts, they express their feelings. So we are practically a being that communicates using words and symbols. So it makes sense if we are able to teach the computers to interact with us using the words we use every day. So it has its roots, down to the 60s, 70s, where you see it evolving. If you remember the first way that humans were using those days, even in Nigeria, they call them the typists that were using the is it, how do they call those things again? Typewriter. You at some point you see them typing. Later, this whole thing evolves into desktops. From there, we have laptops and phones. This portability in the way these things were evolving. So also was how we were communicating with the computer, because the typical computer understands only binary stuff, that's zeros and one. So whenever we need to communicate with the computers, we need to find a way to encode these natural languages so the computer can be able to relate with them. So whenever you say this is a boy, the computer will encode all the characters, even including the space that you hit on the computer, to encode all of them and then translate them into matrices or bag of words. And then from there, it will be able to carry out some sort of probability, and then it will understand which of them should precede another one. Okay? Now, one of the classical challenges we face is the issue relating to ambiguities. For example, when you say banks as river banks, the computer will be confused. Are you trying to talk about financial institution, or you're trying to talk about the normal river bank? So the context also is very important, because sometimes we human beings could be sarcastic, So how does the computer process or detect this is a sarcasm, So that sort of spontaneity that comes up from a human being is not the way the computer could see it. So how the computer relates to these things is very different from how we relate to those things. Sorry, I think somebody is trying to join. Forgive me again. Let me just see if it's still Ben. I really don't know why his network is disturbing, but I hope it go through this time. Okay, so I think it's going through. All right, great. Okay, so those sort of sarcasm, ambiguity, and all that happens makes it quite challenging in order for us to. Then another issue that we struggle with is processing a lot of words. Imagine where you are looking at a whole novel or the whole of internet. These words are extremely challenging for us to be able to process billions of these characters. So sometimes it could really give us quite a very deep challenge. So like I said, when we look at the historical evolution of the natural language processing, it started from the 60s as the handcrafted grammars. Then it was mapped to statistical methods. Then we also have, then in the 90s, we have the n-grams. So we kind of, again, map some statistical, so like when you say this is a medical person, for example, a doctor, naturally the computer will give more weight to a male. But when you say a nurse, the computer will give more weight to a female. So that's why when you tell ChatGPT, for example, generate an image of a nurse for me, you didn't put anything. You will see that it's likely going to give you females. And you tell it generate an image of a doctor for me, you will likely see the computer will give you a male. So that sort of thing arises because of the statistical weights that were assigned to this word during the early evolution of the natural language processing. Then in 2010 onward, we began to see the deep learning taking over, from these classical models, when we now later begin to see things like the long short-term memories coming in, and then we saw the transformer model, subsequently also came in around 2017. from the paper, attention is all we need. So that's how the evolution of this natural language continue to evolve over time. But why does it matter? Because you see, when you looked at all the technology that came across the timeline of human evolution, you will agree with me that each of them wanted to address a specific challenge that the human race were struggling with. One of the reasons the natural language processing have to come was because we need to translate languages. For example, it's not everyone that speaks English. Uh, I remember throughout my stay in Italy during my PhD, my landlady doesn't understand English, and I don't understand Italian. So when she comes, maybe during the end of the month, I need to pay her my rent. She says salty, salty, which means money, and then she'll say luci, that's light, and then aqua, that's water. Or she talks about what other bills do we also have to take care of. Gas, she calls that also. I can't remember what they call that now. Now, you discover that so sometimes when she talks, I will on my Google Translate. And then when she's talking, the Google Translate will be interpreting it from Italian for me to English. And then also when I want to talk to her, I will talk to the Google Translate, tell it converts it from English to Italian. So in as much as it's funny, but that was helping us to be able to understand ourselves and to be able to address, issues effectively. So that was the only way we could really communicate with each other. You know, uh, else it will be very difficult for me to talk with her. Again, it helps us to summarize documents. And you have large documents. There are times when I have a full paper, I don't have the time to go through all the section. Sometimes I just give it to this AI tools and tell them, okay, can you summarize this for me? Highlight all the key points so I could take a look. So that helped me to effectively understand what the document is saying without having to go through everything in it. It also helped me to extract information. Like I said, AI could spot patterns much quicker and faster than we humans could. So sometimes if you don't want to miss the pattern, you tell the AI to take a look at it for you first. So after the AI have worked on it, then you could just do the work of a reviewer. You review what the AI have given to you and see if it conforms to the state of the art in that field. It analyzes sentiment. Of course, if you looked at social media, for example, those people that the social media geeks that likes the likes and the comments and all that. So the behind the hood in Facebook, Instagram, LinkedIn, and all that, there are humans or AI that are tagging each of these comments that you comment on post. It will highlight it if it's a positive comment or if it's a negative comment or if it's just kumsi kumsa. So the reason is because you need to understand that sometimes you don't allow everything to go out there because the human mind emotion could be very, very dangerous sometimes. So that's why you see some persons who say they report their page because maybe the sort of comments and things they were writing could incite people and cause revolution, like we're seeing the Gen Zs across Africa and other parts of the world, like the comments from that guy in Nepal that sparks, a revolution some months ago. And then we saw a flame answered in, was it Madagascar or so? And then we saw it continue to move again across to Tanzania, Cameroon. Unfortunately, Nigeria is still sleeping. So we analyze sentiment, from comments, from like market reviews. Sometimes when you chat with chatbots, we could be able to know. And even when you comment on products, if you're a fan of ordering products online, most times before you buy products, you want to go through the review comments to see what people say about the product. So stuff like that is called sentiment analysis, and this NLP help us to do that very well. It also helps us to generate text like we see ChatGPT does. If we come to ChatGPT, oh, write a poem for me, give me this kind of story, stuff like that. It do that for you. So it helps us to do things like automation, understand insights, knowledge discovery, communication, and access. Okay, there's so much for us. AI helps us. In fact, like I used to tell people, this is one of the wonderful times to ever be alive because so much is being done in the field of AI. Of course, it has its challenges to things around privacy, ethical concerns, lack of trust, interpretability, and all that. But again, you cannot deny the fact that AI is really helping to solve problems that we never thought we could be able to do some years back. Now, what are the core components of NLP tasks? The first thing is tokenization. Now, when we talk about tokenization, it's trying to break the text into words or tokens. Now, because we cannot really analyze the statements if we don't break them into components or fragments, sort of. For example, when you said hello world, the AI will have to break it into hello. Then the space between world also will be on its own, and then world. And even with the hyphen, you could see the hyphen itself stands alone on its own. So it will be able to assign some mathematical weight to this, and then it will be able to analyze it. So that tokenization breaks each of these long sentences, paragraphs into individual tokens. When it breaks them, the next thing it does is pre-process it. And how does it do the pre-processing? It begins to work on things like lowercase. So when you see this hello, which with the H here is uppercase, it turns it to small case. Then we have the stemming and lemmatization. What that does is begin to remove some phrases like, for example, I am running. It splits into the major verb. It focuses on the verb run or something, or verb is an action word, right? Focus on it. It looks at the adjectives, the pronouns, stuff like that. So like running now, it's focused on run. It removes that. So these are like stop words. So it's kind of it identify the root words like you do in normal English classes. So that's what it's going to be doing. So that's quite helping it to be able to put them into a structure that it can organize it into matrix. Because at the end of the day, the computer will see it as a matrix. Then it can be able to carry out different kind of manipulation on that matrix. Then we talk about the future extraction. So the future extraction is that matrix that I just talked about. So what we are trying to do, we convert this text to numbers. Okay, so we use things like TF, IDF, word embeddings, word to vector to create a bag of words. Okay, so that at the end of the day helps us to convert these words, and give them numbers. So some will be maybe 1, some will be 0, some will be 2.5, depend on what weight the computer assigns to each of them. Then by the time we have them in formats we want, the next thing is to begin to model that particular data. So what do we do in the modeling phase? Again, we talk about sentiment analysis. Remember when I told you guys about the sentiment? Is it positive? Is it negative? So we've kind of looked at this kind of sentiment. Or we can also use it for prediction where we generate the next word. So when you say, tell me a story, the computer will now say, what kind of story? The story about a cat and a rat. Then it begins to tell you. So this kind of, it's a prediction or telling you the next things to do. So it generates, but that's when you are talking about chatbots, okay? An example of a chatbot is the ChatGPT things that you talk with, the Google Jamming. And then also for translation, you can also train the model to do translation for you. Then evaluation. So before you release the model out there, you have to evaluate it. Just like a typical traditional machine learning task where we looked at how the performance looks like out there. So for NLPs, we use matrices like the BLEU for translation, or ROUGE for summarization, or perplexity for generation, like the case of ChatGPT. Most times it's the perplexity we use. But if we are looking at summarization, we use the ROUGE, to help us with it. Any question? Do you have any question? But I assume there is no question. All right. Tokenization. In this case, right, remember what I said, we break the long text, the characters, into individual words. So what we are doing is to identify what are the nouns, what are the verbs, and the adjectives. So a typical NLP pipeline looks like this. You have the raw text, you feed it to the NLP models. I remember before that you do your text preprocessing. By the time you do the tokenization, you do the stemming, the lemmatization, the word removal, and all that. The next phase is the future engineering phase. By the time you put it in the right frame or matrix, you do the model, which is, it could be sentiment analysis, it could be prediction or generation of this word. So by the time you are done, you've gotten the model the way you want, you have to evaluate it. Remember, if you are talking about it could be the BLEU, it could be when you are trying to use what do we just called it, the ROUGE, or when you are using perplexity for generation. So any of the evaluation depend on the task you are doing. And then by the time you are done, you will now produce an output. So that's where you now want to make, if you are doing a chatbot, if you are producing, so it depends on, again, the data product that you want to get based on the task. So when you see Google Translate, understands that before you see the Google Translate that you speak to, it has already been trained behind the hood, and it passed through all this process, and it's been properly evaluated before it was deployed as an app that you can communicate with. So there is the Name entity recognition, or NEL, which helps in detecting people, places, or organization. So that's another different model that you could always use for a specific task. Then it could be sentimental analysis, where you assign if it's a positive, negative, or a neutral sentiment to that particular task. It could be machine translation. Maybe you are training it to translate from English to French or Italian, like the example I told you guys. Text generation, like the case of the ChatGPT, where you do that. Now, what are the real world examples? In the real world, you would see things like Google Translate, which is very popular. A lot of us use it, you know. So it's something. If you have your phone, you are likely just going to go in. You see the Google Translate, or you could talk to it. You could text the language you want it to translate to, and it will do it for you. Emails spam filter. Trust me, these have saved a lot of people because so many fraudsters or internet scammers uses they used to send out random email in what we call phishing. So by the time they send these emails to you, some of the email, the moment you click it, it will hack your system and introduce a malware, a ransomware. By the time you do that, you have to pay them in order for them to um, relieve your system. Stuff like that, So this email span help you to detect if that incoming email is from a bad guy, and it quickly divert it to your spam mails, so that by the time you are trying to click your email, you will be very careful with that email, so you don't just fall into the hand of scammers. Funny enough, I think I have talked about this in one of my earlier videos on the YouTube channel, where I talk about these guys. They send people UN jobs. They will tell you, oh, the job you apply on so role, you have been selected to go in for interview or something like that. And then um, it looks, because they target a lot of job hunters, for example, and because you are submitting so many applications, there is high chances you will not remember when you did apply. So it will look like, in fact, some of them will send you email first to apply. So you will apply after maybe like a month or 2 months. They know you have forgotten, then they'll tell you that what you have applied have gone through, you have been selected, this. And then they will follow up later until when they draw you deeper. They will mimic the way the UN jobs looks like. They will do all those things. But the only thing is, they will when you focus very well on the emails, you will begin to see some distortion. So if the UN job is the email is un.org or something, they could put a hyphen. So the same email, but just a little change, distortion. So if you are not someone that pays attention to detail, you can easily get scammed by these guys. So that's why you need to pay a lot of attention to things. And you shouldn't be somebody that is easily moved by things that will make you not to use your brain, because sometimes these things could hype you. You could become so excited, and you won't scare to look at these diligent checks. And before you know, they will trick you into collecting money. And they do that to a lot of people, especially in developing countries like Nigeria and other African countries, where they know that there is lots of desperation. So they do that to a lot of young people. They fall victims of these people, and they scam them a lot of money. Sometimes they could even take a very small money from you. Some could even get to that level of requesting for courses Like they will train you in courses or something. You need to pay maybe $50, $100, and then you pay, you know. But these are not true. That it's not UN. The UN they have this process of recruiting, and the process is very rigorous. So anyone that cuts corners and try to tell you there is a shortage, they are looking for replacement, these are scammers. Don't give them attention. So the natural language processes help us to be able to identify these emails and filter them out. There is the Siri and Alexa, where for example, my television in this house, when I want it to bring something from YouTube, I just talk to the remote. I say, hey, Alexa, I think it's Siri or Alexa. I can't remember which one then again. But I just tell it, I say, can you search for this for me? And then it goes to YouTube and pull it, and I click on it and it goes. So stuff like that. We see these things integrated into IoTs, and we can use them in our everyday life. Social media toxicity detection. Really, the social media space is becoming so toxic these days. The expectation of the people, for example, is not being met. The governments keep running on propaganda. So the only place the people could come and voice their concern is on these platforms, because of course, most African countries, democracy is not, it's just on paper. So when you come out and protest, you are likely going to be kidnapped and hidden somewhere. And then the masses can't protest because they will face brutal action. So the only place they can be able to express themselves is on social media. Like recently, there has been a lot of bad energies in Nigeria on the issues of Christian genocide. When you looked at it, a, a lot of time the government had been clamping down on voices, because they never saw that coming. So they neglected that space. And to their surprise, now they seems to be the underdog on that social media platforms. It seems the citizens now have more voice than them. So now they begin to use threads and all this kind of means to make sure they count people to silence. But so the social media could be very toxic. So what social media organizations like Meta, Grok, and all that, most times they try to mitigate these things by making sure they put some sort of guardrails. So once they detect this toxic sort of uh, tweets or comments, they pull it down or suppress it so it doesn't show up